Okay, so this is question 2, and we've got a graph, which is figure 1, y equals f of x. So we've got some function which is leading to this v shape. The graph consists of 2 line segments, this one and this one, and it crosses the y-axis at the point 0, 11. Then sketch on separate diagrams the graphs of y equals the modulus of f of x, and y equals 2 times f of minus x plus 3. So obviously we'll look at this one here first. So there's our graph, and quite simply the graph of y equals the modulus of f of x basically means that everything that's negative now becomes positive, and this bit here simply reflects in the x-axis to come up here, and we essentially lose this part of the curve down here. And this point that was at 6 minus 1 comes to this point now, call that q prime, which is 6, 1. So our graph is now looking something like that. Okay, part B of this question, we're asked to sketch y equals 2 times f of minus x plus 3. So back to sketch of the problem again. And we're looking for y, as I say, equals f of minus x plus 3. So we'll start from the minus x and work our way out. So f of minus x is equivalent to a reflection in the y-axis. This is the y-axis and this is the x-axis. So this value here, 6 minus 1, goes over onto the other side to minus 6 minus 1. And so we're going to end up with a shape looking something like this. And something like that. Okay, and this is our point 6 minus 1 out there. No, minus 6 minus 1. Okay, and then we apply a vertical stretch of 2 to this. So this value here that went, this intersection here at 0 along 11 is going to go up to 0.22. So that's effectively going to be there, and this point here that at minus 6 minus 1 is going to come down to, say, minus 6 minus 2, say down here, and the curve or the line, the function now looks like this down to here, and comes up this way. And if I drew this accurately, both lines should be going through the through the x-axis at the same place. We try and fudge that a little bit. So both of these should be shown as going through the x-axis at the same place. Okay, so there's one second function going down to there, and the first function coming to here, 6 minus 1 and 6 minus 2. And finally, we've got this vertical translation of 3, so everything is going to be lifted up by 3. So this point here, minus 6 minus 2, goes to minus 6, 1. And this point here, which is now at 0.22, stretch of 2, is now going to go to 0.25. So my function now looks something like this, where this line and this line is going to be parallel. So I've got a line coming down there and a line coming up there. And this coordinate in here is now going to be minus 6, and 3 up from the minus 2 is 1. Okay, so in part C, we're given the form of the function that we've got in the graph. F of x is equal to a times the modulus of x minus b minus 1. And this part over here is where the modulus section comes into effect. And when we apply a modulus, we're effectively multiplying by minus 1. So effectively, in this region over here, we can say that f of x is equal to minus 1, so that becomes minus a times the modulus of x minus b minus 1, which means we've got minus ax plus ab minus 1. Okay, so that looks a bit like the equation of a straight line. The minus a is the gradient, and the ab minus 1 is equivalent to the y-axis intersect. So this is now the equation for this first part of the line. As I said before, the effect of the modulus algebraically, if this part is negative, is to multiply it by minus 1. So for example, if x is, say, if x is less than b and this is negative, then we multiply by minus 1 to make it positive. Okay, so let's get a first, and we can now get the gradient here. The change in y is going to be 11 down to minus 1, which is minus 12, and the change in x is 6. So the gradient m is the change in y divided by the change in x, which is minus 12 divided by 6, which is minus 2. So our value of a must be equal to 2. Minus a times x is what we've got in our equation, minus 2 is what we've got for the gradient, so a must be equal to 2. Okay, now we come to the intersection point on the y-axis, and we know the intersection point must be 2b minus 1. Sorry, it must be ab rather, minus 1. So this point up here is ab minus 1. A we know is equal to 2, and this bit over here must be equal to 11. So we've got 2b minus 1 is equal to 11. Take the 1 across, 2b equals 12, and b is equal to 6. So there's our two values.